Hello everyone, welcome back to ANR Academy. Today we are going to discuss different equations which are in vector form and the equation of straight line as well as equation of plane in various forms. Particularly these are vector equations we are going to discuss now. In geometry there are different types of straight lines. Maybe that is origin form of straight line or slope point form, 2 point form, normal form, symmetric form, different types are there. But in vector algebra, you have only two different forms. First one, vector equation of straight line which is passing through single point A and it is along the direction of B bar. Next, another form, vector equation of straight line which is passing through two different points. Next, three various types of equation of plane in vector form. Let us see the first one. Here the plane is passing through one point capital A and it is parallel to two vectors B bar and C bar. Second one, here the plane is passing through two different points and the plane parallel to a vector C bar. Next, third one, plane passing through three non-collinear points. Let us see the equations and their proofs. First one, suppose there is a straight line which is passing through point A and if it is parallel to a vector B bar. Then to get the vector equation of straight line, what I am doing, observe, you know that every geometrical figure which is path of points satisfies a particular geometrical condition. And here required equation, that is equation of straight line. You know that every straight line which is collection of infinitely many points and all the points are called locus point clearly. The path of points usually denoted by locus point P. Now observe, if suppose P is any locus point, the path of points which satisfy a consistent geometrical condition is known as locus. And here verify the geometrical condition. When you select locus point P and already given that the line is passing through a point capital A, joining these two we get a straight line which is AP vector. If you join A and P, there is a line segment. If you mention the direction from A to P or P to A, whatever, then you will get a vector AP which is clearly parallel to another vector B bar. So that I can write geometrical condition now. Here the geometrical condition, AP vector clearly parallel to given vector B bar. And we know the condition for parallel vectors. When the two vectors are parallel, one can be written as scalar multiple of the other. So here AP vector that can be written as scalar multiple of B vector, where T is real number. Now AP vector I am rewriting this way, OP minus OA, that is t times of B bar, where t is real number. OP indicates position of point P. So that is position vector of P. Next, position vector of A, that is OA here. Generally, OP vector, position vector of general point is denoted by radius vector R bar. Next, and this is A bar equal to t times of B bar, where t is real number. And from this, you will get R bar equal to A bar plus t times of B bar, where t is real number. This is the equation of straight line which is passing through point A and parallel to B vector. Next, second one. Suppose that if the straight line passing through two different points, capital A and capital B, that is 2-point form of vector equation of straight line we are going to discuss now. Yes, again by the definition, every geometrical figure which is by the path of points which satisfies a consistent geometrical condition. Let us see the path of points on the straight line and which condition they are going to satisfy. These are the path of points on required straight line. Somewhere I am going to select locus point P. Yes, I am going to write if P is any locus point, then what is geometrical condition? Observe. Here I can join A and P. Clearly it is AP vector. Also I can join A and B also. I can join AB. So there are two vectors which are AP bar and AB bar. They are clearly parallel. Therefore, geometrical condition I am going to write AP vector which is parallel to AB vector. Again, parallel condition. You know that parallel implies one vector written as scalar multiple of the other. So here, since these two are parallel, AP equal to t times of AB you can write, where t is real number. You know that AP vector written as OP minus OA and AB vector that is OB minus OA. OP vector is position vector of point P, R bar general notation, OA bar that is A bar, next OB bar B bar, OA bar A bar. If you simplify this, finally we get R bar equal to, take A bar terms one side, in one bracket if you write A bar terms, 1 minus t into A bar plus t B bar it is, where t is real number. So these are equation of straight lines in different forms. One is line passing through point A parallel to B vector, and the other the line passing through two different points. This is about vector equation of lines. Next, let us move to the equation of planes now. Yes, you know that three types are there. First one, plane passing through point A and parallel to B vector as well as C vector. The plane is parallel to B bar C bar, but not BC parallel, remember. The plane which is passing through point A, and it is clearly parallel to another two vectors B bar and C bar. This is one case. Next, second one, plane suppose passing through two different points A and B and parallel to a vector, suppose that this is C bar. Next, third one, plane passing through three different points A, B, C. Every geometrical figure that is formed by path of points, and those path of points must satisfy a geometrical condition. Here, plane also formed by different points. Plane is also collection of infinitely many points, right? And these collection satisfies a particular geometrical condition that gives automatically the equation of plane. And here also plane is collection of infinitely many points, and these collection satisfies a particular geometrical condition that gives the equation of plane. For any geometrical condition, for any geometrical figure, you know that is formed by different path of points, and this collection finally gives the figure, and collection of all these points gives the plane. And let us observe the points which satisfying which condition in each case. I am going to select locus point P here in the first case. Suppose that this is locus point P. One of the points I am going to choose. Suppose here there is a point P. Next, assume that there is a point P here. Now verify the geometrical condition in each case. In each case I am going to write the geometrical condition, and the geometrical condition should relate with point P, remember. Just I am going to join A, P, and here I am going to join AP, AB. Next, here I am joining AP, AB, AC. After selecting one of the locus points, just joined AP in the first case. In the second case, AP, AB are joined. In the third case, AP, AB, AC are joined. Now, it is very clear that each plane consists three vectors. Here there are three vectors, and the second case also you have three vectors. In the third case also there are three vectors which are parallel to the plane or lying on the plane. Now, whenever three vectors lies on the plane or parallel to the plane, then we know that these three vectors are coplanar. So I can write here geometrical condition AP and B bar, C bar, they are coplanar. Also here AP vector, AB vector and C vector, these three are coplanar. Next, third one, AP vector, AB vector and AC. These three are lying on the same plane, implies I can say that they are coplanar. We know that when three vectors are on the same plane, then box of those three vectors equal to 0. Or otherwise, you can write one vector is linear combination of remaining two vectors. In the previous case, only two are parallel implies one can be written as scalar multiple of the other. Now one can be written as scalar combination of scalar multiple of remaining two. AP one vector, B and C two vectors. So I can write T times of B plus S times of C. TB bar, SC bar. Where T comma S, these two are real values. Next here, again one vector can be written as scalar multiple combination of remaining two, where T and S, they are real numbers. Here also one vector is linear combination of remaining two when the three vectors are lying on the same plane. So I can write T times of AB plus S times of AC, where T comma S, they are real values. AP vector is OP minus OA, and right hand side TB SC as it is. OP vector is R vector and this is A vector. Now finally we get R bar equal A bar plus TB bar plus SC bar, where T comma S both are real values. Next here, AP, that is OP minus OA. AB vector written as OB minus OA. Now this is R minus A and it is B minus A multiple T, C multiplied by S. Now R vector written as 1 minus T into A bar plus TB bar plus SC bar. If you simplify this, you will get this result, where TS, these two are real values. In the same way, last one, AP is OP minus OA. You know that AB is OB minus OA vector, and AC, that is OC minus OA, and position vector of P comma A, R bar and A bar. Here position vectors of B bar, OB bar, A bar is OA bar, this is C and this is A. And finally, after simplification, it gives the result. If you write A, B, C vector terms in one bracket, you will get 1 minus S minus T into A bar. Next, T times of B bar, S times of C bar, and in this case also T comma S, they are real values. This is about vector equation of planes in different forms, and you can easily remember that T multiple B, S multiple C vector, and here T multiple B, S multiple C vectors. Next, T multiplied by B vector, S multiplied by C vector. When the plane is passing through one point, then you have to write only one multiple, one A bar. If the given vector passing through two different points, then remember that here A vector multiple is 1 minus T. For 2 points, you have to remember 2, 1 as well as t, 1 minus t, difference. If 1 point, only 1 you have to remember, that is coefficient of a vector. And 3 different points, non-collinear points are given, a, b, c. Then remember that coefficient of a, that is difference of 1 s t, 1 minus s minus t. So in this way, you can easily remember the equation of plane. And also equation of vectors, they are very simple. R bar equal to a bar plus tv bar, r bar equal to 1 minus t a bar plus tv bar. Again here it is very clear that you can easily remember t always multiple of b vector. When the line passing through only one point, you have to remember that 1 multiplied by a vector. If there are two different points, then two letters 1 and t, that is difference of 1t, 1 minus t, you have to remember. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.